Hello, my name is Treepat Chantaurai, and this is a part of MS 310 Quantum Chemistry. And today we're going to be learning about Alain aspects experiment, which is the direct measurement and violation of CSHH Bell inequality. And these are the table of contents of today's talk. So first, let's start with Alice and Bob thought experiment. Each of them will be given a box containing a basketball and a football. If one of them choose a basketball, it will be -1, and if they choose a soccer, it will be +1. And for simplicity of emulating the quantum system, which is like an entangled particle, if, for example, Alice chooses a football, the +1, and then Bob will instantaneously chooses a basketball, which is -1 for like conservation of thing. And then EPR paradox rises from that point, which is like how Bob instantaneously know what Alice has chosen. Since information cannot be sent at a speed faster than speed of light, Einstein and the others, his colleagues, claiming that quantum mechanics is incomplete, and there's gotta be hidden variables behind the decision of Bob and Alice even before the measurement itself occurred. And then there's John Bell, who's trying to quantitatively measure and systematize the EPR paradox itself. He only assumed two things, which are locality, which is information that you cannot send information at a speed you cannot be sending information at a speed faster than speed of light, and causality, which is properties have definite values whether or not we measure them. And these are the correlation and the S value, which will be very important later on in the experiments, because if the EPR products, EPR's hidden variable theory wanna be hold, the S value needs to be strictly less than 2. And then here comes Clauser's first valuation experiment. So he did use calcium atoms to emit entangled photons to two sides of the setup, and then measure each of them's each polarization. And what he was trying to do is that, for example, if the photon spin is up and the polarizer is up as well, it will be +1. And if the direction of the spin and the polarizer is different, it will be -1. And if the polarizer is horizontal relative to that of the spin, it will be left and right 50% of the time. And the real question comes in, what will happen at an angled polarization during the measurement? And that is the difference that yields different result from quantum mechanics and classical theories. And the limitation of Clauser's experiment is that he uses single channel polarizer, which transmit one polarization and block the orthogonal one. So he essentially only measured +1 and didn't measure the -1. So we cannot be sure whether the signal that we are not like measuring got blocked on the way, or it's just because of the low efficiency of our detectors. So Alain aspect came in to like finally to improve that loophole. So he uses two channel polarizer to measure more access of polarization to overcome that efficiency loophole, as can be seen in the 4 measurements in the picture. He did use calcium radiative cascade as a source as well, and that 2 channel polarizers, it can measure all 4 coincidence rates in a single run simultaneously, just like in the Bell's inequality terms. So now we can measure R++, R +-, R -+, and R -— simultaneously at the same time. So we're not like missing any of the signals. And then we will calculate the S value from that, and then if classical theories hold, the S value need to be less than 2. And the result comes, and we have correlation between no, we have the information between the correlation and the angle, and the S from the experiment is 2.697, which quantum mechanics expected it to be 2.7, and this hugely violates the Bell inequality, which predicted it to be strictly less than 2. And what's remaining? The remaining loopholes are the quasi-periodical aspect of shunting oscillation that hinders the validity of the experiment, and each of the paralyzers, the 2 plus and 2 minus, are linked by physical wires in this experiment. So induction or like effect from that wire can be impacted the result of the experiment. That's it for my talk. Thank you for your attention.